All right, so this is it. We're wrapping up our discussion on variation relationships with this video. And there's only one thing to talk about, and that's situations where you have multiple different types of relationships. And so that's what this video is about. We're going to see things that are direct, we're going to see things that are indirect, and we're going to see both of those things happening in the same problem. So with that said, let's take a look at our learning objectives and let's get started. Our 4 learning objectives for this video are exactly the same as what they've been in the other 2 videos on this discussion. You need to know the vocabulary associated with these types of relationships. Fortunately, in this particular video, there's only going to be 1 vocab word, so that won't be too bad. You'll need to find the constant proportionality. That's going to be exactly the same as it was in the last couple of videos. You're going to need to find equations. That's going to be almost the same as the last couple of videos. The only difference is you're going to have multiple pieces to work with, and you'll see that in just a second. And last but not least, you'll need to solve problems. That's exactly the same as the last video. Okay, so we're just going to jump straight into an example in this video. In this first example, what we're going to do is look at a relationship where x varies directly with y and indirectly with z. X varies directly with y and indirectly with z. So you can see what we mean by multiple relationships. There's a direct relationship, x varies directly with y, and there's also an indirect relationship, x varies indirectly with z. And both of these are happening in the same problem, okay? So with these types of situations, you're only going to make 1 equation. You're only going to have 1 constant proportionality. It's all 1 problem. It's just 1 problem that has more than 2 parts to it. All right. So here's the question that we're going to answer in question number 1, or example number 1. We are going to find the constant of proportionality. We're going to find the constant of proportionality. Okay, so the first thing I want to do is I want to build an equation or a model or a structure that I can use to solve this. And here I'm working with 2 different types of relationships. There's a direct relationship. And we know from our first video that direct relationships use this type of an equation. But there's also an indirect relationship. And we know from our second video that an indirect relationship uses this kind of an equation. Okay, now one thing to notice is that both equations use k. And k, remember, was a constant of proportionality. They both are using k, the constant of proportionality. And so k in the first equation is the constant of proportionality. K in the second equation is constant of proportionality. It's the same k. It's the same thing. So when I write my equation for this problem, even though I have multiple relationships, I'm only going to have 1 k. And so what I need to do is go through and start fitting the pieces together. Now, in this particular example, there's a little bit of a trick, and I've played this on you on purpose. What we looked at in the first video was in a situation that said y varies directly as x. And that's how we made this equation. But notice here I've switched it. Instead of saying y varies directly as x, I've said x varies directly with y. So I've switched my x's and my y's in this particular problem. X is the thing that's based on these other variables. X depends on y, x depends on z. So x is going to be the thing that's by itself. Okay, we know it doesn't matter if it's direct or indirect relationships, everything is going to have an equals k. That part's going to be the same no matter what. But now what I need to do is fill in, where do the y and the z go? Well, y, because it's directly related, y is going to be a situation where it's k times y. And then z, because z is indirectly related, z is going to be a situation where it's k divided by z. And so with these types of problems, really the biggest trick is sorting out the English so that you can figure out where the variables go in the math. But once you end up with that structure to work with, now everything from this point on is the same as it was in the first two videos. If we're going to find the constant proportionality, we're going to need to plug in some numbers. Oh, I just realized I didn't give you any numbers. All right, let's have some numbers here. So we're going to find the constant proportionality. I left a little bit of space here. I'm going to squeeze my numbers into this little space right here. So hopefully you've got some room where you can squeeze in some numbers. So x varies directly with y and indirectly with z. When y equals 3 and z equals 2, x is equal to 12. There's the numbers that I'm going to use. Okay, I'm not sure how I missed that when I wrote the problem down originally, but there we go. So now I've got some numbers. Now I've got an equation. Now I can find the constant proportionality. It says that x is equal to 12. So my x is going to become a 12. I still have an equal sign. I still have a k. I still have a fraction. But now I fill in the other bits. Y is equal to 3. So where the y is, I'm going to get a 3. And z is equal to 2. So where the z is, I'm going to get a 2. And so that becomes my equation. And now I can solve for k. And there's lots of ways to solve for k, just like before. You can solve this any way you want. In fact, you might want to pause the video and give it a try and see what you end up with. All right. Hopefully you've tried it, but if not, that's fine. You can watch me. Me personally, I'm going to stick with what I've been doing for the last 3 weeks of working with rational expressions and rational equations and rational functions. I'm going to put this 12 over 1, and then I'm going to cross multiply. Now, this is certainly not the only way to do this problem, but it's the way that I'm going to choose to do the problem. So when I multiply going in this direction, I get a 12 times 2 equals, and then in this direction, I get 1 times k times 3. 1 times k times 3. Okay. Now, one comment that I'll make right here, because sometimes students make this mistake, is remember when we multiply, we just multiply in order from left to right. But if we need to, if we want to, we can switch the order, we can move the order around, and that's okay. But when we're multiplying, there's no distributive property for multiplication, right? I would need somewhere in here to have a plus sign if I was going to ever use a distributive property. Since there's no plus signs, there are no minus signs, there's no distributive property. So I just multiply 12 times 2, well, that's equal to 24. And most people would get that fine. But over here, some people would be tempted to distribute that 1, okay? That's not how it works. We just multiply straight across. So 1 times k, that equals k. K times 3, that equals 3k. So I just multiply straight across, okay? So there is what I end up with when I simplify that. And now I need to divide both sides by 3. So I don't really have a lot of room to show my work, so I'm just going to do that in my head. If I divide both sides by 3, I'm going to get 8 on this side, and I'm going to get k on this side. And since the problem just simply asked me to find the constant proportionality, now I have done that. And so that's going to be my answer. Okay, now that's our first example, and that's the general idea that you're going to see in these problems. The one thing, though, that we haven't talked about yet is the vocabulary. In this problem, there was no new vocabulary. All the vocabulary that we saw here, we've seen before in the previous videos. But there is one vocabulary word that we need to know. And so I want to wrap up this video by introducing the final vocabulary word for this unit, and that is the word jointly. Jointly. J-O-I-N-T-L-Y, jointly. Right? Jointly refers to a situation where there are multiple, and you'll just have to know from the problem whether it's 2, 3, 4, whatever, the problem will tell you. But jointly means there are multiple direct relationships. So anytime you see the word jointly, We're always talking about direct relationships. Never are we talking about indirect. All right. So let's take a look at a quick problem with this. Example number 2. Let's say that D varies jointly with R and T. D varies jointly with R and T. Okay. If D equals 50, when R equals 2 and T equals 25, then find a model that relates D to R and T. All right, so there's example number 2. If you need to pause the video to get that written down, go ahead and pause it real quick, get that written down. But there's our problem. So what we're saying is jointly always refers to a direct relationship. So another way to say this is D is varying directly with R and T. Okay, so jointly means that it's multiple direct relationships. So it varies directly with R and it varies directly with T. That's what this sentence is saying. So if we think about our direct relationships, we know direct relationships are the type of relationships that are linear. They look like K times X. So if I take that and apply it to this situation, D varies with the other stuff. So D is the thing that's by itself. There's always an equals K. Just like on the last problem, even though there's multiple things, I'm only going to have one K, and they're all direct. So I'm just going to have times these things. So I've got K times R times T. So there is my structure that I'm going to use. Now for the next piece, I'm going to plug in the numbers. D is equal to 50 when R is equal to 2 and T is equal to 25. So I would simplify both sides. Well, this side is already simplified. Over here, 2 times 25 is 50, and then 50 times K, well, that's just 50K. So that's where I would get after I simplify. And you can probably see already what K has to be equal to. But if we show our work, we would divide both sides by 50, and we get K is equal to 1. All right. Now, this time the problem asked us to find model. Remember, model is another word for equation. So we're going to go back and we're going to use this form that we had, and we're going to plug into it this value of K, and those two things together will create our model. So D equals 1 times RT. Well, in this case, I would simplify because 1 times anything just equals itself. So there is our model, D equals RT. All right, so that is an example of joint variation, and that wraps up our unit on variation relationships. So thanks for watching this video. Have a good one.